Hello, Ms. Treadway here. We are going to continue talking about triangles. Today we're going to be covering some things about triangles and angle theorems and side angle theorems. So first we want to start off with some terms and new vocabulary. So the first thing we're going to talk about are some different ways that we can classify triangles. And one of the first ways that we can classify triangles is by the length of their sides. And so we can do this in three ways. We have what are called scalene triangles, where none of the sides are congruent to each other. So might not be super clear here, but none of these tick marks on this triangle match up. None of the sides are congruent to each other, so that is a scalene triangle. Another way we can classify them by their sides is an isosceles triangle, in which at least two of their sides are congruent. So if I labeled this triangle ABC, and this was an isosceles triangle, that would mean that AB is congruent to BC. So isosceles, at least two of the sides are congruent. And lastly, we have an equilateral triangle in which all three sides are congruent. Okay? So that's classifying triangles by the length of their sides. Another way we can classify triangles is by the measure of its interior angle. And we have four ways to do that. The first one is going to be an acute angle. And this is a triangle in which all three angles have a measure less than 90 degrees. So in this first one here, I have a 50, 74, and 56. Those are the measures of my angles. So none of them are equal to or greater than 90, so they're all less than. So that is an acute triangle. All right, another way we can classify triangles is if they are obtuse, and that is when they have one angle that has a measure greater than 90 degrees. So if you look in this example here, this angle B has a measure of 110 degrees. That's an obtuse angle, so this is an obtuse triangle. Okay. The next one we have is a right triangle, and we know that. That's where we have one angle that's equal to 90 degrees. And this would be angle B again right here is 90 degrees. And lastly, we have what's called an equiangular triangle. And this is when all the angle measures are equal. Now, because a triangle's sum of its interior angles is 180 degrees, if they're all equiangular, that would just be 180 divided by 3, which is 60. So in an equiangular triangle, the measures of the angles will always be 60 degrees. Now, something to note about equiangular triangles is that they are also always equilateral. So if all of their angles are the same measure, then all of their sides will also be the same measure. So same thing goes for equilateral. If I have an equilateral triangle, I know that it's also going to be equiangular, and I know that the measure of its interior angles are each going to be 60 degrees. All right, now we're going to talk about two quick theorems to wrap up section 3.6. The first one is what we call the triangle sum theorem, and this is something I've already said previously, but the sum of the measure of the angles of a triangle is always 180 degrees. So in this triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C will always be 180 degrees. No more, no less. And one corollary to that, which is something that we can conclude based on this theorem, is that the acute angles of a right triangle are complementary. So if I have a right triangle here, remember if the total sum of the angles is 180 and a right angle is equal to 90 degrees, so if I subtract 90, I have 90 left over. So these angles A and B would need to add together to be 90 degrees. And remember, two angles that equal 90 degrees are complementary. So the acute angles of a right triangle are complementary to each other. All right, we are now moving on to section 3.7. I know 3.6 was super short, sweet, and to the point. So now let's talk about a couple more theorems, and then we're going to work some problems. So starting first, we're going to talk about some theorems that have to do with isosceles triangles. And remember, isosceles triangles are triangles where at least two of the sides are congruent to each other. So first, let's talk about some vocabulary and terms. So in my isosceles triangle here, I have two legs that are congruent to each other. So these are our legs. The side at the bottom is what we call our base, and the angles that are adjacent to the base are what we call our base angles. Then at the top we have our vertex angle, and this little point up here is our vertex. Okay, so that's some terminology about the different parts of our isosceles triangle. So now that we're familiar with that, let's talk about our isosceles triangle theorems. And the first one is the base angle theorem. And it says that if two sides of a triangle are congruent, excuse me, then the angles opposite them are congruent. So if AB is congruent to AC, then angle C is congruent to angle B. Okay? And then the converse of that theorem would be that if two angles of a triangle are congruent, then the sides opposite them are congruent. So if I already know that B is congruent to C, I can conclude that AC is congruent to AB. So that's the converse of that theorem. So it goes both ways. If I know the sides are congruent, then I can conclude that the base angles are congruent. If I know that the base angles are congruent, I can conclude that the legs are congruent. All right, so something else to note is that if two sides of a triangle are not congruent, then the angles opposite them are not congruent. And vice versa. If the angles of a triangle are not congruent, then the sides opposite them are not congruent. Okay? And then one last thing we need to know before we can start some practice problems is that the largest angle is always opposite the longest side of the triangle, and the smallest angle is always opposite the shortest side of the triangle. So in this triangle here, my largest angle is 109 degrees. So this side opposite, that is going to be my longest side. And my smallest angle is this 23 degrees, so the side opposite that angle, that is my shortest side. And we have now made it to our last page of notes. So one more theorem is going to be that for the lengths of the sides to form a triangle, the sum of the smaller two sides must be greater than the third side. So let's look at these examples here and determine whether or not they can form a triangle. So starting 5, 6, and 8. My smaller two sides are 5 and 6. The sum of 5 and 6 is 11. So 11 has to be greater than my third side, 8, in order to be a triangle. Is this true? 11 is greater than 8? Yes. So yes, those three sides could form a triangle. Now what about 2, 3, and 7? My smaller two sides are 2 and 3. Their sum is 5. Is 5 greater than 7? The answer is no. So no, those cannot form a triangle. 6, 7, 13. 6 and 7 are the smaller sides. Their sum is 13. Is 13 greater than 13? No, 13 is not greater than itself, so the answer is no, this cannot form a triangle. All right. 4, 4, and 6. My two smaller sides are the 4 and the 4, which sum is 8. Is 8 greater than 6? Yes. So yes, those can form a triangle. And last but not least, 2, 2, and 2, they're all the same measure, so I can just say 2 plus 2 is 4. Is 4 greater than the third side? And the answer is yes. Can anyone tell me what kind of triangle this would form, 2, 2, and 2? That would be an equilateral and equiangular triangle. All right. Now let's get two little practice problems using the new knowledge we have about triangles and their angle side theorems. Starting here with number 1, I'm told that the measure of angle A is greater than the measure of angle C. And then I want to find the restrictions on the value of x. So remember, my largest angle is opposite my longest side, and my smallest angle is opposite my shortest side. So if I'm told that angle A is bigger than angle C, then that would mean that side BC would have to be larger than the measure of side BA, because those are the sides opposite. Okay, so I can use these expressions here to write an inequality now and find the restrictions on x. So this is my inequality, and I'm going to rewrite it. BC has to be greater than BA. And so BC is 8 minus x. BA is 4x plus 48. So this inequality I now need to solve for. I'm going to move my x's to the left side. I'm going to move my constants to the right side. So I'm going to get minus 5x is greater than 40. Divide both sides by negative 5. And remember, when you divide by a negative, your inequality sign flips directions. So I'm going to get that x is less than negative 8. But I'm not done, because there's one other thing that has to be true in order for us to have a triangle, and that is that our measure of our sides cannot be 0 and it cannot be negative. So that means that each of these expressions has to be greater than 0 in order to be true. So I need to say that 4x plus 48 is greater than 0, and I need to say that 8 minus x is greater than 0, and solve each of these inequalities for x. So for this one, I'm going to move 48 to the other side, and I solve, and I get that x is greater than negative 12. And then for the other one, I can just move x to the other side, and if I wrote that the other way around, it would say x is less than 8. So I have two less than expressions here. I have x is less than negative 8 and x is less than positive 8. So let's eliminate one of them. Let's talk about a number line here. This is positive 8 and this is negative 8. If I already know that x has to be smaller than negative 8, I already know I'm restricted to this side of my number line. So I can eliminate this inequality. It's redundant. I know it has to be smaller than that. So my final expression for the restrictions on x are going to be that x is between negative 12 and negative 8. And that's the answer to practice problem 1. All right. And last but not least, problem number 2. And I do have a small typo here. I want to correct that to say BC. So if I'm given that BC is greater than AB, find the restrictions on the value of x. So again, remember, BC is bigger than AB. So the angle here must be larger. Angle A must be bigger than angle C, because my largest side is opposite my largest angle and my smallest side is opposite my smallest angle. So this is the inequality, that I am going to plug in my expressions for. So I'm going to have that 6x minus 45 is greater than 15 minus x. And I'm going to solve for x. So I'm going to move all my x's to the left, all my constants to the right, and I get that, I'm sorry, this is 15 plus x, so I would subtract it here. So I'm going to get 5x is greater than 60. And so that gives me that x is greater than 12. But remember, my restrictions need to have two values. So for this one, because I'm talking about the measure of angles, I can say that the measure of angle A plus the measure of angle C has to be smaller than 180 degrees, because I have three angles here. So this other angle needs to be have at least 1 degree of measure. It can't be 0 and it can't be negative. So the sum of these two has to be smaller than 180. So I'm going to plug in my expressions again. And I'm going to solve this inequality to get the other half of my restriction. So I'll combine my x's, and I'll combine my constants, and solve. And I get that x is less than 30. So x is between 12 and 30. And that concludes our notes for today.